So as I'm sure you've come to appreciate, the world of distributed computing and Hadoop in general is massive, enormous. There's a lot to it. We haven't even touched on everything that you might run across. So let's quickly go through some of the other technologies that you might encounter throughout your career in the big data world, and at least make you conversant in them. So these are a bunch of things that aren't necessarily directly related to Hadoop. Some of them are, but they are at least things you'll hear talked about or you might have to integrate with. So I want you to at least get a slide on each one. One is Impala. So Impala is basically Cloudera's alternative to Hive. It's a massively parallel SQL engine built on top of Hadoop. And we talked earlier about how Cloudera is a very popular distribution for Hadoop, in the corporate world in particular, and it has a few proprietary things that it uses to set itself apart, Impala being one of them. Now technically, Impala is now an incubating Apache product. It's open source, but it is managed by Cloudera, so it is kind of their thing still. And good luck running it on Hortonworks. It's supposedly possible, but I've never seen it actually done. The thing that sets Impala apart is that it's always running, so it's always sitting there ready to execute queries, as opposed to Hive, where things have to spin up and kind of like figure out how it's going to execute when you execute a Hive query for the first time. So Impala is really made more for BI style queries, business analytics, where you're actually trying to interactively issue queries on your data, interactively, and you want a response pretty quickly. So that's what Impala is for. Bottom line, it's usually faster than Hive, but Hive can offer a little bit more versatility because it is, more widely adopted and there's more connectivity between Hive and other systems in general. But if you are on the Cloudera platform, consider using Impala instead of Hive for your quick little BI queries. It is a value add for Cloudera, but remember it is Cloudera specific, so learning Impala isn't going to help you if you end up managing a Hortonworks cluster down the road. Accumulo. Accumulo is another big table clone like HBase is. So think of it as HBase, but with better security. And this is also kind of an up-and-coming alternative for NoSQL databases. It offers what's called cell-based access control. So you can have very tight control over who can see what data in Accumulo. That's something that HBase doesn't really offer. HBase does have security capabilities, but not at this level. Another thing that Accumulo offers that's not in HBase is server-side programming. So you can have little snippets of code that transform data as it's coming in on the server side. So if you do have complex security requirements and you need a NoSQL database like HBase, consider using Accumulo instead, but make sure the systems that you need to integrate with can talk to Accumulo. Redis. So if you've done any distributed server work before, you're probably familiar with something called Memcached, or the idea of having a cache that backs your web servers. Redis is basically the next generation of Memcache, if you will. It's not actually directly related to Memcache, but it serves much the same purpose. You can use it to actually provide in-memory storage of information that is accessed frequently from your applications. And because it's in memory, it's very, very fast, right? But it's much more than a cache. It doesn't just store key value data like Memcache would. It can store entire data structures like hash maps and things like that. And it can also persist that data to disk automatically, which means you can really use it as a persistent data store and not just a cache, but it is just as fast as Memcache is, which is kind of amazing. So even though you can have it persist to disk, it can still be just as fast as a memory-only cache like Memcache. And like I said, for web apps, this is a popular caching layer that's quickly taking the place of Memcached. And I only bring it up in the context of this course because it is a source that you may need to write data to or import data from. And you'll see that some of the streaming solutions we talked about do offer connectivity to Redis. Ignite. You can think of Ignite as an alternative to Redis. So Ignite is an Apache project, and it builds itself as an in-memory data fabric. So it also provides in-memory data storage and access, but it's closer to a real database. Not only is it providing in-memory access to your data, but it also provides database-like features like ACID transactional guarantees or SQL support. So for things like transactional financial transactions, it might be suitable for that sort of an application even. But it's all done in memory, so it's super, super fast. So Apache Ignite is pretty exciting stuff if you want in-memory processing of your data that can actually act like a database. So it's worth another look. Elasticsearch, very popular system. It's not directly related to the world of Hadoop, but again, it's something you might be exporting data to or importing data from. It is basically a distributed document search and analytics engine, and it's very popular out there. For example, Wikipedia uses it. So if you search for something on Wikipedia, that's going through Elasticsearch to try to figure out which documents match your search term the best. Also used by companies like The Guardian and Stack Overflow and many, many more. It's actually pretty hot, and it's probably going to be the subject of an entire course at some point from me. It can also handle real-time queries, like, when you start typing in a search term and you start to see results as you're typing, it can even handle that sort of a thing. And when you pair it with something called Kibana, you can do these really cool-looking interactive explorations of your data and do queries on your data to actually get cool little graphs and histograms and whatnot, and really explore and analyze the nature of the data that's stored in Elasticsearch indices. Amazon also offers an Elasticsearch service, so spinning up a scalable Elasticsearch cluster is very easy to do. So very cool thing. Kinesis. So speaking of Amazon, let's talk about the whole Amazon Web Services ecosystem. AWS, Amazon Web Services, is basically a product offered by Amazon to allow you to rent time on their massive clusters of computers for whatever applications you want. And Kinesis is one of many offerings that they have in AWS. Kinesis is basically the AWS version of Kafka. So AWS has its whole ecosystem of sort of a parallel universe of its own features that are often found in open source Hadoop solutions. So for example, S3 is a popular distributed storage solution, so you might use that instead of HDFS. There's an Elasticsearch service we talked about, Cloud Search as well. DynamoDB is a lot like Cassandra, but that's their implementation of it that you can just spin up an instance of very quickly and using their hardware and rent it by however much you need it by. Amazon RDS is a way of renting time on a relational database like MySQL that you can just spin up and use whenever you need it. Elastic Cache, again, an in-memory caching solution like the ones we just talked about, like Redis. And there's also a whole suite of artificial intelligence and machine learning services that I'm pretty excited about that are emerging now. So AWS is an entire world in which you can run distributed computing, and they do have their own proprietary versions of a lot of the technologies we've talked about. But with EMR, Elastic MapReduce, that's a way to just spin up a honest-to-God Hadoop cluster that has things like Spark pre-installed on it. So if you do want to stick within the open sourcey world, you can still do that with AWS as well. So moving on, Apache NiFi. NiFi is a way of constructing directed graphs of data routing, and it can connect to sources like Kafka and HDFS and Hive, and it has a nice web UI for designing complex systems and data flows. So I often see this in the context of managing massive input streams from sensors and Internet of Things applications and things like that. So it's mostly relevant in the context of this course in that it can be involved as a data source for your streaming applications. So a lot of times when you look at examples for Spark streaming or any streaming framework really like Storm, you might see NiFi as an input source that it uses. So this is just a way of organizing the flow of data that's coming into your cluster, and then it's up to you to process that in some way. Falcon. Let's talk about Falcon. Falcon is basically a data governance engine that sits on top of Oozie. And we're talking about it because it's included in Hortonworks, so you'll see that on the list of services over on the side there in Ambari. So like NiFi, it allows the construction of data processing graphs, but it's intended to manage the flow of your data once it's already inside your cluster. So think of it as a layer on top of Oozie. Really, you're only going to be thinking about Falcon if you have so many workflows in Oozie that you need a manager for the manager, if you will. So if you're in a world where you have thousands of Oozie workflows that themselves need to be orchestrated and scheduled, Falcon is worth a look. And finally, let's look at Apache Slider. Also one of the pre-installed services in Hortonworks that you'll see on the list there. It is just a deployment tool for general applications that you want to distribute on your Yarn cluster. So if you have your own application that you've written, Slider is a way of deploying it to your cluster, monitoring that application, and growing and shrinking its capacity over time. So you can use Slider to control how many instances of your application are running across your cluster and start and stop them as needed. It is technically an incubating Apache project, and it's still in development, but it is part of the default Hortonworks installation, so I think it's worth a mention. So there you have it, the best of the rest. Let's move on and talk about how to put all these pieces together.